Francesco, you're very kind, perhaps a little bit too kind, and I'll try to do you some justice. I want to thank you for the invitation to come here. Most of the people in the audience know more about Erlang than me, probably far more about Erlang than me. So I feel honored to be invited to close this conference. And Stockholm has been, I always keep a top 5 list of places in the world that I want to go. And Stockholm was right up there, and it's a pleasure to check one off. But it's a bigger pleasure to check off a place and then come there and find that it meets and surpasses everything that I thought that it could be. You have a beautiful country, you're an amazing people, and thank you for welcoming me. I want to start this talk with a story. I am a mountain biker, and this is a little part of a trail. I like to climb, and it's not quite as steep as that spiral staircase there, but almost. And it's a little bit wider, but if you start on the upper left and then go around counterclockwise, the first picture is kind of looking through this big crack in the rock, and the next picture is of texture. And so picture yourself riding up this on a mountain bike with big rocks, and probably every second or third time I'll blow the climb and then have to step off, always in the same place. And that's the third picture. Or I'm sorry, the third picture is looking at the crack from the top, and the fourth picture is the place that I always put my foot when I blow my climb. Now, on a particularly bad day, I messed up in the first couple of feet, and I was kind of mumbling and grumbling, and I was walking my bike up, and then I heard a buzz, and I looked to the right in that place where I would normally put my foot. And there's a big rattlesnake sitting there looking at me. And I have thought philosophically about this moment many, many times. And in fact, I didn't take on mountain biking for that kind of pain, right? But it impacted me more than I thought it would, even though I didn't get bit at all, if that makes any sense at all. In Texas, we have an expression. I say snakebitten so I don't come across as an uneducated hick. But in Texas, we call it snake bit. Ain't nothing never good happened to him. He's just snake bit. Now, normally when people are snake bit, they're snake bit for a reason. Bad things don't just keep happening to people without a cause. Normally, I add this extension when we're dealing with programming languages. You get snake bitten basically because you're trying to solve a problem, and you come up with unintended consequences. So Francesco mentioned that I wrote a book called 7 Languages in 7 Weeks. And that also made me philosophical. It made me think, there are some really cool languages out there. Why didn't these languages succeed? And why did the ones that we've been, kind of burdened with, why did they succeed in the mass market? And that's kind of what we're going to look at during this talk. So we're going to spend a lot of time with a language tree, or a language timeline. And I did some heavy research here, Wikipedia, and built a rough list and just threw down some of the ones that I found as interesting. And then I thought about what some of the things were that were happening at the same time. And then I thought about what are some of the architectural models that we settled on. And then I thought about the impact of all of those things onto the programming paradigm. Because languages don't succeed or fail in a vacuum. They succeed or fail based on what's going on at the same time. And Joe has experienced this quite a bit. So what's going on here is that there are a series of things that are happening in the marketplace that are pushing hard, exerting heavy pressure on the languages, those that fail and those that succeed too. So let's talk about the first block of languages here. Really, it's one language. This was before we had higher level languages. It's assembly language, and it's basically tying a single instruction to a single block of memory. And at this point in our evolution, before 1955, it's important to point out, we tend to take computer design for granted. We have an architecture called the von Neumann architecture, and it's impacted language design probably bigger than any other early influence. But I want to point out that von Neumann computers were not the only kinds of computers. In fact, my brother worked on a battleship. I think that this is one of the sister ships. My brother worked on the Iowa. And if you look at the little clusters there, they're hand cranks. And the reason that that's important is that these aren't bits and bytes. And what this computer did was take certain things into account, like the direction of the chip or the motion of the waves or things like that, constant inputs, and it would output an elevation or a firing solution, right? Direction and elevation for a firing solution. This was called the Mark I computer, and it was not a von Neumann design, but the von Neumann architecture eventually won, and it had a pretty significant impact on us. And we'll talk about what that architecture is and what that impact is as we move forward a little bit. Which takes us to the first collection of languages. These are the first high-level languages, and you can see that there's a cluster of languages in there that you recognize, and one that you may or may not recognize. But if you think about it, what is it that is special about Fortran and COBOL versus what is special about Lisp? Lisp was written, about 50 years ago, a little more than 50 years ago. What was special about it? Well, it is a far higher level language. It has a very impressive meta model. It has functional concepts, and you compare those to the COBOLs and the Fortrans of the world. And when you think about that, when you think about the reasons that drove the success or the failure of those languages, it's easy to get pretty frustrated. In the United States, we had this show. Did you guys have Celebrity Deathmatch here? So it's a claymation show. It's often pretty violent, and they might pit Madonna against Michael Jackson and say who would win or something. And they would beat each other up in pretty crass and irreverent ways. But we're going to have our first Celebrity Deathmatch, right? So think about it. Lisp supports the higher order functions, the garbage collections, the systems, the data as code, all of these very powerful ideas. And you compare that with COBOL, right? And you say, who's going to win? Oh, I know who's going to win. But no. How did that happen? So we're saddled with code basically today. If you're in the mass market, now I realize that we're in the Erlang community, but if you're in the mass market today, you're probably doing Java. If you're really a smart guy in the mass market, you may be moving towards Ruby or something, or Python or something that's a little bit more, a more modern object-oriented language. But you still have code that looks like this. And I can see Joe here going, boo, mutable state. Wait a minute, Bruce, those values are going to change over time. If you bound X twice, no, don't do it. And we have a lot of words for this. Mutable state, or if you talk to the founder of Clojure, Rich Hickey, he talks about this idea that we're binding identity to value, right? So identity is bound to value, and as time changes, that binding can change. And it's very difficult to get concurrency models right. I mean, you've probably heard about this all weekend, and I'm not going to say anything else about it. So you got the idea. So the von Neumann architectures is really what's going on here. So we imagined the way that languages should look because we knew what the computers looked like underneath. We had this thing called a program counter. The program counter would move, and different registers or values would change over time, right? And we wrote our languages to match the von Neumann architecture. Now, it's okay. How many of you think that I'm actually full of it? You could raise your hand. Okay, you are way too polite. But some of you are thinking there is no way that 40 years later, or even 20 years later, anybody would think of the von Neumann architecture as having a great impact on the programming languages. Now, I was looking at as I was doing research for this book, I looked at a 1977, 22 years after what we're talking about here, after the creation of Fortran. I looked at a 1977 Fortran user's manual. And this was the first image in the book. Direct, cut, and paste. So they were saying, hey, philosophically, what you should be thinking is that this is a computer, so this is what your programming language is going to look like. And what we wind up with is a snakebite. The snakebite we call mutable state. And that one's going to stay with us for a while. It's still with us, and it's the one that's going to be in our way that we have to get through if we're going to solve. If you look all the way down the third column, the very bottom, it says multicore. We've got to solve that snakebite before we can move forward here. Okay, so let's talk about the next family of languages here. And this is really the next programming paradigm, which is procedural programming. And in fact, a lot of people are going to go to school around this time frame and learn in something like Haskell, a highly structured language, and they'll go to work and write something like C during this time frame. I actually graduated from college, or actually started college at the beginning of this period, and finished it with more structured programming and the model that we'll talk about next. And in fact, I did learn Pascal and go to work in C. But there were some other very interesting things that were happening at the same time. We aren't just talking about simple procedural languages. There are things like Forth, which is a radically different programming paradigm. Smalltalk, it's an object-oriented language, and it's actually, I think, a much better, cleaner, simpler language than the object-oriented language that we started with. And gosh, what else is interesting here? VisiCalc, I think, is a fascinating look at really another programming language. It's a spreadsheet, but if you think about it, this is a programming language that has powered all the financial communities across the world. In fact, we have these massive programs that everybody depends on, that the Wall Street and European financial systems all depend on being right. This code is written once by people who are not programmers. It is not tested, and the stuff by and large works. It's a pretty powerful programming model. It's actually more of a functional programming model than an object-oriented model or a procedural model. But yet, we picked something else, right? So the deathmatch here is between, I'm so sorry. I told you the winner before. Okay, the deathmatch here is between Smalltalk on the top and C on the bottom, between beauty and verbosity, but between a more practical and pragmatic performance-oriented language and kind of a beautiful applications language, right? And C wins. And if you look at this victory, it's not just a little victory. It's a victory that'll stay with us for decades. And in fact, if you look at a site called Language Pop, and now I know that this isn't an accurate measure of the popularity of a language, but just for a snapshot, look at the top 1, 2, 3 languages there, right? They are, if you can't read them there, they are C, Java, and C++. They're the same syntax family, right? And then there's Perl, the world's only write-only language. Then there's JavaScript. So that's 4 out of 5 based on a C syntax. And then there's Python, and then there's C#. So that's 5 out of 7 of the top languages based on a syntax for a language that was built to write operating systems. And we're doing everything in those languages, right? So the problem is that the applications that most of us write, the business applications, web applications, things like that, the needs are very different from the needs of a language that's built to build operating systems, right? So if you're building operating systems, you need explicit allocation, bit level control, weak flexible types. Actually, a lot of the things that Erlang gives you. And if you're building more of a business application, you need cleaner garbage collection. You need stream manipulation, reliability, right? So if I'm a business user, you would have expected somebody completely different to win that deathmatch. Maybe it's Smalltalk, maybe it's Haskell, maybe it's one of the other higher level languages. Because the choice for business versus performance is really control versus productivity, or performance versus expressiveness. And we chose wrong. So we took the more specific use of building business applications, and we said, hey, I want my business applications to be fast. I'm going to write in C. And that's the way the mass market works, right? So we have a snakebite. In this case, we're saddled with a programming paradigm that's imperative versus functional. We're saddled with a syntax that is C-like, that's good for the job, but not great for business applications. We're saddled with a type system that we're still struggling with and trying to get right, and the various programming idioms that started with the AT&T language that was not written for what we did with it. Now I want to point out something here. One of the reasons that Smalltalk didn't succeed out of the gate, and out of the gate was 1970 or so, but it stayed in the picture for a long, long time and never quite broke through. And one of the reasons is that when you're designing a language that has a different paradigm, and Joe has gone through this, it's very difficult to get people to adopt a new programming paradigm right off the bat. You have to have a bridge language that kind of introduces some of the new ideas. And for the world, when we moved from the world of procedural programming or structured programming to the world of object-oriented programming, we had a couple of bridge languages, right? The most obvious one is what? From C to C++, right? Did we write object-oriented C++ code? No. It was all structured, procedural C++ code, right? So it was really like a C++ minus minus. But the introduction of C++ was still very important to us because it started to introduce the ideas of object orientation and what they could do for us and how they could help us better organize code. In fact, there were other bridge languages as well. If you were in the government, you were probably using a language called Ada, which introduced the idea of encapsulating data and behavior. So, which brings us to the next family of languages, or the next programming paradigm, object-oriented languages, right? Now, if you look at this list, and being in the crowd in the Erlang community that you're sitting in the chair that you are today, this one probably hurts a little bit. This is probably probably the first time where you say, hey, the mass market could have made the right decision. They made the evil decision, right? Look at all the cool things that were going on at the same time. I mean, we all know that Erlang is great. I mean, I've come to love this language. But there's also, gosh, probably the best typing model of all time, the Haskell typing model. See, for the longest time, I thought that I hated static typing, and I realized that I just hated static typing as it's done in Java and C#. But look at some of the other cool things that were going on at the same place. I think that you're going to laugh at me for saying this, but I think that Visual Basic was actually a very effective language for delivering business applications. Now, that's a hard thing to say. Normally, I should be doing something like, do you like Visual Basic? No, but my brother likes it, or something like that. But, so there are some other cool things that are happening at the same time. Ruby is starting to grow a little bit in Japan, but really still keeping a very low profile at this point. At the very end of the chain, you have JavaScript that came out right on the heels of Java, and you have C#, which are, basically, C# and Java are basically the same thing. And some of the things that impacted us were, the REST paper and the introduction of Netscape and EJBs and the .com bubble, right, that wound up bursting. You can sense a pretty powerful theme here. But there's something behind the theme. When you see a programming paradigm change, you should always be looking right under the surface for what the business driver is for the new programming paradigm, right? When we moved away from assembly language, it was because our programs were getting too tough to keep in our head, right? We needed better organization. So we needed just enough organization for the language to be very accessible, but not too much to where, not more power than our users could handle. So if you were looking at the business need, then COBOL and Fortran probably seemed a lot safer. Now, if we're thinking back to just before the proliferation of the internet, what's happening if you are an IT manager? This is your problem. You have tens of thousands of servers. You have hundreds of thousands of workstations. You have on that an operating system. You have a networking system. You might have a communications manager. I remember for OS2, we had the OS, the operating LAN manager, database manager, and comm manager. And we had customers out there that deployed all of those things with tennis shoes and roller skates and diskettes, right? And if you had a bug in the operating system, it often required you to reload all of the stack that was on top of it as well, right? And IT systems were drowning. It wasn't just the deployment problem. There was also an explosion of complexity. And this is not going to end. As long as time goes forward, we're going to expect more and more and more out of the people sitting in these chairs. You need to be able to juggle bigger ideas in a tighter density, right? And these are the forces that were facing IT managers at the time. Now, if you look at this list, you know who's going to win this next deathmatch, right? And you have to feel for the Smalltalk people, right? This is their second shot at things, right? Oh, C++ is finally melting down. We got them this time. Boom. Right? Because it wasn't about the elegance of the programming model. It was about deployment. The Java explosion was about deployment because you could park a browser on that system one time, and now you have your whole business suite of applications. And what we were sold, I know this because I was in sales support at IBM at the time, and what we sold our customers was that you could design applets that magically flew in from the sky and solved your IT problems, right? And eventually that merged onto servlets, right? Which meant that we were building the same batch green screen applications that we had 30 years ago. But that's not what we believed or what we were telling customers at the time. There were a lot of death matches that were going on at the same time. If you were a business user or a business manager and IT was not keeping up, your natural inclination is to go build things for yourself, right? So many of those managers said, I can get my head around Visual Basic. Visual Basic is relatively simple, right? I can have this magic OK push button, and hanging off of that, I can have about 10K of code, crank that application out very quickly, right? But it's not about the programming model. It's not about accessibility. It's about deployment. Boom, right? You guys heard of this language? the right tool for the job, right? So you might be asking yourself, okay, I believe you, it's about deployment, so why can't I just pick something that's smart for me? Manager, I've got this job that I can do instantaneously in Erlang. And your boss says, Java. And so you get this troll on the left side of Joe's slide that says banned. It wasn't a troll, was it? What was it? Some kind of creature there. Anyway, and you get this ban message from on high. Because what the managers see is that integration with C++ was so incredibly difficult and painful that there's no way I want to solve that problem if I invite more than one tool into my IT shop. One ring to rule them all, and in the darkness bind them. Right? So Java is maybe the best winner of all time. And we were talking about this over lunch. One of the things that happened when Java won was some of it was good, right? There was probably the biggest community, the most successful series of conferences of all time. You guys remember Java 1 in San Francisco. They didn't even have to go anywhere else. Everybody came to them. And there were sometimes 10, 15,000 people at those conferences. And they were incredibly successful. But one of the other things that happened is a lot of the other conversations around the world dried up, right? And if you think about it, there's some things that Java got right. The portability and the ability to do the things that Java eventually did in the browser. It basically saved IT. IT basically went from 2 years behind to, maybe 6 months behind. But if you look at some of the problems with Java, it's pretty clear that there are some serious snake bites. Now, we still get to drag along all the baggage from before, right? We have mutable state, only we've multiplied mutable state because we've said an object is philosophically combining the ideas of state and the behavior, right? So we're going to be riding that horse even harder now. We also we're saddled with the C++, the idioms, and also some of the typing model, but more importantly, the syntax, which may be the wrong syntax for the problems that we're trying to solve. And we have some new snake bites, like the typing model. These are the decisions that the Java team made. Static, and what was Smalltalk? Smalltalk was much more dynamic, right? And explicit, meaning you had to type int, public static void. You had to basically explicitly type everything, and normally not just twice, but more times throughout the life of the program. And we had something called, if you're going to be statically typed, you have a choice. You could say, I can bind the type to the name, or I can bind the type to the meaning behind the name. I can bind it to the structure. So these are the decisions that Java made, and these are the decisions that a lot of people say that they would have made instead. And Joe actually made a great point about this in an earlier talk where he said that, that Erlang's dynamic typing allowed him to express some ideas in a smaller, more concise way. And when you combine that with Erlang's let it crash philosophy, you have all of the safety and all of the benefits of a smaller, cleaner typing model. So when you think about these, don't think about the academic concerns. Think about the problems that they solve for you. So for example, when you think about static typing, you think, when do you bind? Right? How tightly do you couple your software? When do you bind, and how tightly do you bind? When you think about explicit versus inferred typing, you think about how much do you type? Do you want strong typing with your strong typing? And when you think about, what's the last concern? Nominal versus structural, it's what do you mean? What does this piece of code really mean? Is it really wrapped up in the name? It's probably not. So, and then if you look at the binding problem was particularly egregious to me. In the Java world, you might say, okay, tightly coupled software, that's just an academic concern. Early binding, no problem. Until you look at all the frameworks in Java that have tried to solve that problem. How many of you have used Java and actually coded in the Java space at one time in your life? Okay, so I'm going to throw some buzzwords at you that are related to the binding, right? First, there's the idea of component models, right? And Java objects weren't enough. Why? Because they were too tightly coupled. So my tools needed to use these things called Java beans. But the Java beans weren't really enough because I couldn't graft on the behaviors that I wanted because Java beans were too tightly coupled. So I created this thing called EJBs, right? I probably didn't get that right the first time. The second time will be better, EJB2, then EJB3, right? And then finally, we had an acronym called a POJO, a 4-letter acronym for the same object that we started with in the first place, plain, ordinary Java object, right? You can sense that there was a lot of consternation about this snakebite. And then if you look at containers, we had the same problem. We had EJBs 1, 2, and 3, and then we finally said, no, we don't want a container. We'll have Spring, which lets us load POJOs, and we'll graft on things by what's called reflection. And then that was too slow, so we actually said, okay, I think it's probably a good idea to take the bytecodes and then so compile the code, and then that's still too tightly coupled. So I'll manipulate the bytecodes and shove behaviors in there, right? We really did that, and that was called the Spring framework. And then there's the idea of specialized containers, because you don't just have this problem for ordinary Java beans, you have it for your database, right? You could have said EJB, Hibernate, JDO, right? We're trying to solve this problem, and we're suffering over these problems, but the problem isn't in the database layer, the problem is in the language, right? And then we did the same thing with networking layers. We did the same thing with remote procedure calls. And so if we want to really harp on typing, now I know that there are clean ways to do static typing now. In fact, I think that Haskell probably has the object model or the typing model that most of us wish that we had. But if you're doing typing with an object-oriented program, I think that the extra complexity and the binding concerns make dynamic typing almost necessary. I wouldn't swear to this, but I think that I'm probably right. So one of the things that I particularly like about Ruby is, there's this annoying thing that when you have an empty string, or it might also be nil, I have to check for something that's nil or the empty string, right? And I have to do this over and over. Well, in Ruby, what I can do is open up the nil class and say, hey, I'm gonna give you a method called blank, and for nil, I want that to be false. For string, I want to return true if the self is the empty string, and for object, I want it to return true for everything that it's not false on. For arrays, I want to return true if the array is empty, right? So then I could say, for any object in Ruby, I could say, are you blank? And it knows what I'm talking about. Even though they're disparate types, they support the method blank, so I can treat them the same. Okay. So Java kind of started multiplying the snakebite effect. It carried along the snakebite for mutable state. It grafted on the snakebite of the snakebites that we brought along for C, and then we added the type snakebites, and then we added all of the threading, concurrency, and process-oriented snakebites. And Java turned out to be not such a great language to be building everything in. Right? There's some things that Java did for us very well, but if we look back at at what could have been, oh my! I mean, I think that we picked pretty wrongly, right? So here we are, and look at that list of languages. Look at the languages on that list that are workarounds for things in Java that suck. That's absolutely amazing to me, right? And look at the challenges, or look at the inventions of the last, I don't know, what's that, about 15 years? And the one on the bottom has me pretty scared, right? Multicore. The people in this room aren't scared. I'm building a Ruby application, right? I chose Ruby knowing that it was going to enhance my productivity out of the gate. But knowing that, like Twitter, the second from the bottom there, they succeeded in Ruby enough to have a scale failure, but their success bought them the freedom to rewrite. That's my model. That's my model, right? But I know that I am not going to, in 5 years, be writing, solving the concurrency problem with threads and locks, right? We all know this. So, I have a couple of observations. The first one is on this language list. You start to see some bridging happening, right? The most obvious one is the Scala language. It has the object-oriented concepts and is trying to build on top the functional concepts. That particular pairing scares me to death because it's actually grafting on, it's carrying along some of the same old snake bites, right? The biggest one being mutable state. I think that we have to get away from that problem, and I think the only way to get away is with a more dramatic break. I might be wrong here. This is the business problem that is going to drive us into a new programming paradigm. It's going to happen. It's going to happen. So right now we're talking about 4 cores, 8 cores, and you can make Java programs work by accident in 8 cores that only crash occasionally. When we get, and hey, I'm not immune. In Ruby, what I've done is said, hey, 1 core is enough. I'm going to run everything in its own process, in its own thread, right? And so what's happened is that Moore's law, the law that says we're going to double in speed every year, in football, we have this play called a punt, right? Where the offense has the ball and they can't go any further. And so they kick the ball, right? And they give it to the other offense and they trade sides with the defense. And they say, defense, you got this, right? I failed, you got this. So what has happened is that the hardware guys have said, hey, that physics thing is kind of tough. And, you know, they're 3 atoms thick. We did the best we could. We can't make them any smaller, right? So we're going to stack chips up now, and you have to solve the problem. The people in this room have to solve the problem. Or what happens is that our computer economy, the premises that all these companies that are based on that we're going to double in speed every 7 years, that can still happen. But you have to make it happen, right? So people have been talking about the emergence of functional languages because they're better and cleaner and cool. That's not going to do it. What's going to do it is we're going to move to functional languages because we have to. We don't have a choice, right? So this will be the next programming paradigm. You might say, well, hey, what if something else emerges? And my point is that things cannot emerge quickly enough. They need to already be on our radar. We need to have already had some experience with the bridging languages, and not just things like Scala, but in Ruby, I've been exposed to closures, and I've taught people to code that way. We're starting to think in terms, in functional terms, even in the object-oriented space. Right? And I want to point out something else that's particularly encouraging to me. We talked about the one true ring to rule them all, and in the darkness bind them, right? There are some integration technologies first that I think are very effective. I can partition a system with REST and some of the technologies that you built in Erlang, or there are similar technologies in the Clojure space. I can partition a functional program much more simply than I can partition an object-oriented program. That gives me hope that maybe the next winter won't necessarily be a single dominant winner. I'm not making that prediction. I still think that there's going to be one language that that garners more share than the other ones. I think that that's just the way the world works. But that's just a guess. I do see a little bit of a ray of hope in this place. I like more of a polyglot world where we can choose the languages that are best for solving the job, because I think that type of diversity spurs all kinds of invention, and it also competition makes a much more effective marketplace. So I have a couple of lessons, and I hope that this will help us wrap up the conference. Why do languages emerge? Why do great languages emerge? First, do you guys think that Erlang is a great language? Clap for yes or silent for no. Yeah, I actually agree with you. Why do great languages emerge? Joe, do they emerge because they're great languages and because they're cool? No. They emerge because you solve a critical business problem. And it's no accident that Erlang was developed in Ericsson Labs to solve a critical business problem. It just so happens that the whole industry is catching up with you in the business problem. We realize that we're going to have to be building distributed concurrent applications. There's no choice now, right? Languages emerge because they solve a problem. Not a bunch of critical problems, but there is one big problem that creeps up on the world that has to be knocked down, right? The second question is, why do we get snake bites? How do we wind up in the place that we are, where most of the industry is still writing in a C syntax, in a language that was built for an operating system? We chose that as the language for our business applications, and we're still using it, 30-something years later, almost 40 years later. I think that what happens is that we apply a specific solution, right? C is fast, to more general problems, right? We don't do the critical thinking for ourselves. So, the third question, I'm at an Erlang conference, and you're going to say, hey, Bruce, what's the winner? Right? Or let me change the wording around. Rather than asking yourself, what is the winner going to be? You should be asking yourself another question. What can we do to make Erlang the winner? Right? What can we do to make Erlang the winner? Or if there's no true ring to rule them all, what can we do to make Erlang more relevant? So there will be a bigger, more helpful community. There will be more opportunity for Erlang jobs. There will be more Erlang employers. There will be a bigger ecosystem, so I don't have to write as much myself, right? That's what we want. I have 3 charges for you. Some of them, if you're from Sweden or from cultures like the culture here, they might be more difficult. Some of them are going to feel very natural for you. The hard one first. So, right? People need to know about how spectacular this framework is. When you have a success, you need to tell something about it. You need to do your lightning talks. You need to speak at conferences. You need to blog. You need to tweet, right? Anything that you can do to tell people about success. You're not bragging about yourself. You're trying to share the wealth, the things that Erlang has given you. So my first challenge to you is to become a salesman. Right? The second one is embrace. You know, there are communities out there that when they start to have tension, part of the community takes their ball and goes home. One of the reasons that we're not talking about Lisp is that I can fairly ask you, which one? Right? There have been so many fights within the Lisp community and so many splits and divisions that for a while it was unrecognizable. Now Lisp has another shot with the Clojure with the Clojure community that's pretty much consolidating around a single strong vision, right? But there are some things that are going to be happening in the Erlang space that are really important. One of the things that Erlang does very well is the JVM. Another thing that it does very well is OTP. I'm sorry, the beam. Oh, that's a bad slip. Snakebite, snakebite, snakebite. You're like the JVM. No. So so one of the things that Erlang does well is the beam, and another thing is OTP. One thing that I found myself missing, I would be coding in Erlang today if the Erlang meta model was stronger. Enter Elixir, right? Maybe it doesn't have everything, but this is part of the ecosystem that can really have a big impact on Erlang and help the whole ecosystem grow, right? And the last one's going to seem a little bit weird. It's a really important one that when you have a community, that you help other people also embrace the new technology, right? One of the things that I loved about the Ruby community is the founder of the Ruby community. His name is Mats, and a famous expression in the community is, Mats is nice, so we are nice. And he's a close friend, and that rings true to me. So what you had was basically a language that was very successful at doing what it did. So Ruby wasn't built to be a commercially successful language. It was a language that was built to make programmers happy, right? To be easy on the eyes, to do the things that the programmers of the time wanted it to do. And Ruby didn't get very successful right off the bat. It took the Rails framework and showing people how to use this meta-programming, which is really why I moved into the Ruby space. And still, that wasn't enough for success. When all those Rails people said, hey, that's cool, they had this great Ruby community waiting on them with open arms. They were very inviting. They were a very friendly community, and they made embracing Ruby fun. And so my 3 challenges to you are not to be afraid to sell, to embrace the interesting stuff that's going on, and to love. So that's what I have to say today. And do you have any questions? Thank you. Are there questions? Oh, that's wrong.
They all agree.
Yes.
Would you like to take a shot at what the next business critical thing will be after Multicore?
I don't think that there's ever a next business critical thing. I think that there's one driver. And I think that if you look back at all the emerging paradigms, we knew that assembly language wasn't going to last too long because you just can't put that much stuff in your head. So the first business challenge was complexity. The second one was procedural language. Let's see. Actually, the second challenge was probably also complexity, because at the time that C was emerging, you also had networking and database coming into play, and so you had to write much more complex code faster. And then the next programming paradigm, object-oriented paradigm, was deployment. We were thinking, basically, there's always an undercurrent that the current programming paradigm is running out of gas, right? There's just more that I have to keep in my head than I can organize with this particular language, which is just a tool, right? It's an organization tool. But then there's a catalyst. When I talk about the business problem, I'm not talking about the underlying, the inadequacy, the mounting inadequacy. I'm talking about the catalyst that sets it off. And with Java, it was very clearly deployment. And I think now it's very clear that the problem is concurrent programming, not just on multicore, but also in distributed applications, right? So the next business problem is probably 20 years out. If you look at 1955 Fortran, 1975, ish, C, 1996, Java. I mean, we've had pretty regular changes. And I think that Java put off the inevitable a little bit by changing the programming model with aspect-oriented programming. So really, Java with AOP is more like Java++, right? And it's just heading off the inevitable. You can see it starting to mount and starting to happen because all of these languages that are workarounds for problems in Java, right? But multicore is it, and I'm very confident of this fact. Yes, you had a...
What do you say about there is a trend that people like modeling, and that you should create graphical modeling like UML and then generate executable code from that one?
Visual programming.
It's like Java with pictures, I think.
Yeah. I don't think I even have to answer that. I mean, you said Java with pictures. Okay, so I was working with, we actually talked about a company called OTI, which was Object Technology International, that built a very successful Smalltalk virtual machine. And then IBM bought them. And they said, hey, we should do programming with pictures. So we had Visual Age, which you could do the user interface, but you could also do ands and ors and stuff with arrows. And you didn't have to write a lot of code. You could do business applications with only this much more scripting, right? And the problem is that there's always the ideas that you can express with today's visual programming techniques aren't rich enough to express the business rules with the density that you need. So what happens is that you augment the visual programming model with code, and we just can't keep it in our heads anymore. It's not an object-oriented model or a functional model anymore. It's the visual model plus the functional code, and we can't keep that straight. We can't refactor it. We can't. It breaks down. So yeah, Java with pictures is a pretty good description. Now, I know that I'm coming across as a Java basher. I'm really not that. I think that Java did some great things for the time. But when you look at the language list up there, got to admit, it's a little unfortunate, right? More questions? Yes?
You are very good to see the trends in programming computer science. And now Java will become functional. They will embed. No, I mean, in next version.
That's Scala.
It's true. It's a fact. I mean,
that's Scala.
They will add the lambda function in the next Java. So what do you think about this trend? It's not the only thing they copied from Erlang in Java. What do you think about the trends?
I see. So the question is, what about functional extensions in Java? What if the next thing really is J++, but it's a real J++, a functional Java? Okay, so I see 4 real contenders. Let me first answer what you asked, and that's, where do you see a functional Java? I think that there are significant problems in the community first because they expect backward compatibility. And if they can't get something like Clojure's built inside of gosh, what did it take? 10 years almost? Then they don't have a prayer at more radical change. And I have this on the word of somebody very high in the Oracle organization that I can't use his name on stage, but there are some significant barriers to real change without backwards compatibility in Java. So there are also challenges with the JVM. There are state problems. There are it's basically a virtual machine that was built to support the Java processing model, the Java threading model, the Java memory model, and the Java stateful behavior. So let me put that fear out of your mind. You don't have to have that nightmare tonight, right? The contenders that I see, now I'm going to put that fear back. I'm going to give you that nightmare. Scala, I think, is a real contender. Bridge languages are important. I think that Scala probably is not a clean enough break with the past, and we might have the J++ minus minus. That's a real fear. But counterbalancing that, we have to get multicore right, And I think that means that one of the more pure functional alternatives will win. And those are Most likely Erlang or some derivative like Elixir or some combination thereof, more likely a combination thereof. Haskell, which may not be accessible enough. This might be the Lisp versus COBOL of 2013, right? We're more likely 2015. Gosh, what am I missing? Clojure. Clojure, I think, what you have is essentially a unified Lisp that's on the virtual machine that has a very significant install base. And the founders of Clojure, most specifically Rich Hickey, he's theoretically brilliant, and he gets a whole lot of the stuff right. So, and then I'm gonna offer a fifth alternative. Really, there are three major ones that I mentioned. I don't really think that Scala will win because I don't think it's a big, clean enough break with the past. I don't think that Haskell will win because it's not accessible enough to programmers today, and I don't see how it can get there soon enough. But I think that we really have a shot this time of the right tool for the job, which would be a welcome improvement. I mean, I think that there's a natural there's a natural benefit to all the languages involved when there are competing languages and when there are great synergistic ideas that can emerge between them. So I didn't pick a winner. I'm not going to pick a winner. I wrote 7 languages in 7 weeks, mainly because I was afraid I couldn't pick a winner. And I thought there were a lot of people like me that need to be learning how to compare languages by doing something non-trivial in them. So that's still where my head's at. More questions?
One last question.
You haven't mentioned F#.
F# I kind of put as in the Haskell umbrella, much like I put C# in the Java umbrella. But it's an excellent language, and Simon Peyton-Jones is, gosh, he's brilliant. And it has absolutely fabulous leadership in the Microsoft organization. Yep. So, but that's a flavor of that's when you look at Haskell, that's a derivative of Haskell. That's got to be in that mix. Yeah, so there was a comment, I didn't catch it all, but there was a strong preference for something like a language conference, and the idea that languages can change the world, which I wholeheartedly agree with. Yeah, I'm not hearing you very well, so. But thank you so much for the invitation. I think it's an honor, and I've really enjoyed my stay here.